these are the notes for day 7, Unit 7, Day 1. And the notes are titled, What is the Difference? And so we're going to be looking today at how these different patterns tell us what type of function we have. So we're looking at pattern design and how it relates to the type of function. And so what we're going to do is we're going to look at this first pattern here with these blocks. It says write a sequence for the number of blocks used to make this figure. And so a sequence, that's the first kind of vocabulary word we're looking at. A sequence is literally just a list of numbers. And so what we're going to do is we'll label this figure 1, we'll label this figure 2, this figure 3, and this figure 4. And then we're going to literally count the blocks. So we've got 1 block here, and then we've got 1, 2, 3 blocks here, 1, 2, 3, 4, 5 blocks here, 1, 2, 3, 4, 5, 6, 7 blocks here. So a sequence then is taking those numbers that we found and separating them by commas and putting them in a set of brackets. So that's a sequence. So that pattern for this pattern of blocks is 1, 3, 5, 7. And then it goes on. It says find the difference. So now we're going to find the difference in the number of blocks used between each pair of consecutive figures. So consecutive is next to each other, right? So find the difference. So the difference between 1 and 3 is 2. The difference between 3 and 5 is also 2. Difference between 5 and 7 is also 2, right? This is going up by 2, in other words. So that's the difference. And if we notice, the difference is constant. And so when the difference is constant, so when the difference equals 2, and when it's constant like that, then that gives us some insight as to what function this pattern of 1, 3, 5, 7, what function that it represents. And so because the difference is constant, we call this a common difference. Okay, so if we think about this, if we think about building this, we build the first shape, we set down a block on the table. We build the second shape, and we add these 2 blocks, one on the side, one on top, to the first shape. And then when we make the third figure, we're going to add 1 on the side and 1 on the top again to make the next shape. And so we see that pattern. We're adding 1 on the side and 1 on the top to get to the next shape. So our common difference becomes that pattern of adding 2 blocks to the previous shape to get the next shape. So we can then write that as, let's see, our y is saying use, let me change colors here. It's saying use the common difference to write an equation of the pattern using x as the figure number and y is the number of blocks. So x is the figure number. I had the figure number be orange, and y is the number of blocks. So we'll just say the number of blocks is pink. So in building this, we're saying then we are starting with 1 block, and we're adding 2 blocks for every figure we move over from the first figure. And so this is, this becomes kind of a really recognizable pattern, right? This is our start value, and this is our common difference, we'll call it CD. And it's really the equation for a line, right? It's really, if we wrote it 2x plus 1, it would look like mx plus b, look like that pattern. So we have a linear pattern here. Okay, so let's keep looking at more patterns. So now it says write a sequence for the number of blocks used to make each figure in this pattern. So we'll call this figure 1, figure 2, figure 3, and figure 4 again. And so the sequence here is that we have 1 block here, we've got 4 blocks here, we've got 3, 6, 9 blocks here, looks like 4, 8, 12, 16 blocks there. So our sequence is 1, 4, 9, 16, and we want to know what function that represents, that pattern. So let's look at that common difference again. Let's look at that difference between the pattern numbers. So 4 is 3 bigger than 1, 9 is 5 bigger than 4, 16 is 7 bigger than 9. So we don't have a common difference anymore. We don't have a difference that stays the same. So for this question here in part B, it says, is there a common difference? And the answer is no, there's not a common difference. No, it's not constant. But there is a pattern. If you look at that pattern goes 3, 5, 7. So that's kind of interesting. And so let's take a look at the next step then. Let's take a look at, if you notice in part C, it says find the difference of the differences. So in other words, looking at the blue numbers, the difference, we're going to find how that changes. So we can call this maybe the second difference, because it's the second time we're calculating a difference. Maybe then we need to call this the first difference. And so when we look at the second difference, 5 is 2 bigger than 3, 7 is 2 bigger than 5. So now there is a common difference. So in here, yes, there is a common difference now. The common difference is 2, but we had to go to the difference, the second difference, to find it. In other words, we had to look at the difference of the differences to find that. And so let's see if we can see a pattern now in the blocks. So we're going to look for a pattern now, where y is the number of blocks and x is the figure number. And so 1, 4, 9, and 16, if you look at those numbers, if we look at that compared to the figure number, right? So figure 1, the block is 1. Figure 2, the block is 4. Figure 3, the block is 9. Figure 4, the block is 16. So it looks like we're squaring the figure number to get the number of blocks. So it looks like to get to the number of blocks, we're taking the figure number and squaring it. And so now that pattern we know is quadratic. And so let's continue to look at the patterns. We've got one more pattern to look at here to kind of hopefully see the pattern of what's happening here. It says write a sequence number for the number of blocks you see here. So we'll call this figure 1 again, figure 2 again, figure 3, figure, oops, that's not 4, figure 4. I guess we got 5 figures this time. This is figure 5. And we'll write our sequence. So we use 1 block in that first figure. We've got 1, 2, 3, 4 blocks in the front, 5, 6, 7, 8 blocks with 4 more in the back. This next figure looks like we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, but then we've got a row behind that and a row behind that, so that's 27. And this one looks like 16, right? The faces of these look like our last example. But we've got 4 rows of 16, so that's 64. And then this is our new figure. We haven't gone up to figure 5. But it looks like 1, 2, 3, 4, 5. So 25 in the first row. And then another 25, and another 25, and another 25. And another 25. So 25, 50, 75, 100, 125 total blocks there. And so that is our sequence or our pattern of numbers. And we want to know what function that pattern follows. And so we're going to look at our differences again. So let's take a look at that first difference. And I think that first difference, you can see it's not constant, right? So that first difference is what we're looking at. And this is a first difference of 7. And this is 19. And this is, wow, I've got some subtraction to do here. 37. And this is 61, it looks like. Okay. So that first difference is not the same. So is there a common difference? And the answer here is no, it's not constant. No, not constant. So let's keep following what we've done before, right? We're going to look at the difference of the difference. That was what, red? Okay, the second difference. So the second difference in this case. So looking at the difference of the differences, so that looks to be 12. This is definitely not 12 because this is my sloppy handwriting. This is 37. There we go. So that is 18, it looks like. And then this is, let's see, 37, 47, 57, 24, that looks like. So still not constant. So is there a common difference now? And we're looking at the difference of the differences, and the answer is still no. It's still not constant. So we're going to do this again. And I think we can see definitely a pattern now. So we're going to look at the third difference. The third difference. And the difference between 12 and 18 is 6, and 18 and 24 is 6 again. So we have, we're looking at the differences again, and we're looking for a common difference. And now, yes, yes, the common difference equals 6. So we had to go out for 3 common differences to get a constant, 3 differences, excuse me, to get a constant common difference. And let me just go back up and check my color coding here. So now we're back to writing an expression where x is the figure number, whoops, and y is the number of blocks. So we're looking at y equals, and then let's take a look at the figure number. So we've got 1 and 1, and 2 and 8, and 3 and 27, and 4 and 64, and 5 and 125. So that looks like a cubic, right? 1 times 1 times 1 is 1, 2 times 2 times 2 is 4, 3 times 3 times 3 is 27. So our pattern is y equals x cubed. And so we're looking at 3 different models to make these, 3 different arrangements to make these 3 different mathematical functions. So how is this type of equation different from the equations of 1 and 2? And the answer is that they're all a little bit different. If we look at equation 1, we had a linear, right? Maybe something like this if we would graph it. That was linear. And number 2, example 2 is quadratic. So that looked like this. And our example that we just got done with, example 3, is cubic. And so that looks like this. And if we noticed the common differences, the linear had one, we only had to look at the first difference. And the quadratic, we had to look at the second difference. That's where we found the common differences. And then the cubic, we had to look at the third difference. Okay, so this is where we found the common difference to be for each one of those models. So if we notice then, if we would write those models, it was 2x plus 1 and x squared and x cubed. So if you notice, the common difference became the power on the x there. So, so each of the differences adds a power to the exponent on the model. And so then we start to talk about the degree of the polynomial. So the degree of the polynomial is that highest power of x in the expression. So the linear one would be a first degree polynomial. The quadratic would be a second degree polynomial because the power is 2, that's the highest power. And the cubic would be a third degree polynomial. And that's really what we're focusing on is how do we identify these polynomials? And we identify them by their degrees. And so when we look at the learning targets here, the things to focus on, the first learning target is just the idea of a polynomial. And a polynomial is a multi-term, and we have terms of constants and variables with whole number powers. So we have terms, this is kind of wordy, terms that contain constants and terms that contain whole number powers on the variable. So whole number, those are positive powers. Okay, so for example, like we had x squared, x cubed plus 2x plus 7. Those would be examples. Non-examples, I'll put it outside the box because it's a non-example. X to the half, that's not a whole number. X to the negative 4, right? A negative isn't a whole number, that's an integer. So those would be non-examples. Learning target 2 is talking about the degree of a polynomial. So the degree is the largest power or exponent. Let me rewrite that. Largest power. When I say power, I mean the largest. Look for the largest exponent. And then we have a general form, sometimes called a standard form, although I think general form is probably better. And that's where you list terms in decreasing power. So from highest power to lowest power. So general form would be like y equals x to the 4th minus 7x cubed plus 4 for x squared minus x plus 7 or something like that. That would be general. That would be general form. And then the last learning target is the idea of common differences. And so when we're always searching for that common difference. And so when we're finding the differences, we find the differences of the outputs. And we do that, and the number of differences it takes tells you the degree. So I'm not quite sure how to do that. So the number of differences, or the difference number, where the common difference is or exists, that equals the degree of the polynomial. So if we look back in our 3 examples in the notes, we saw that, and this is this is a kind of a quick look through the notes. The third difference was common, so this was a 3rd degree polynomial. And the second difference was common, so this was a 2nd degree polynomial. The first difference was common, so this was a 1st degree polynomial. So we can set up the model like that and just keep calculating the differences. So we have some check your understanding here. It says determine which of the expressions are polynomials. For each polynomial, identify the degree. So these are all well, I shouldn't say these are all polynomials, that's not true. So just don't forget to simplify, and let me just do this real quickly. This simplified is 7 divided by x, which is equals 7 times x to the minus 1 power. So we got to look at the powers, make sure they're integers. So integer power, excuse me, not integer, I said that wrong. Whole number power. Whole number power. So that the whole number power is 0 and all the positive numbers. And so you can look at that, and then it says find the degree of the polynomials here. So you're going to look at the common differences again, and you're going to the differences. So let's look at that first difference, and if that doesn't work, go on to the second difference, and so on and so forth.